Since April of last year, NASA's Juno spacecraft has performed a series of increasingly closer encounters with Jupiter's volcanic satellite Io. Images and other data returned from Juno have revealed how Io has changed in the 16 years since it was last seen up close by New Horizons. This weekend, Juno will perform another encounter with Io, this time at a distance of only 11,500 kilometers or 7,200 miles. In this video, we're going to look at what we hope to see during the encounter and what we hope to learn from Juno's instruments. Before we can take a look at Juno's next flyby of Io, we should look back at what JunoCam observed during an encounter with Io at the end of July. Juno's closest approach distance to Io was about twice what it will be on Sunday morning, but the ground track and lighting conditions were similar. JunoCam observed Io's northern trailing hemisphere with pixel scales down to 15 kilometers per pixel. Even at that scale, these images revealed never-before-seen details of Io's north polar region, as well as provided more detail of changes seen at Voland and Cors Patera. Io's far north was revealed to be dotted with tall mountains, including one that reaches a height of nearly 6,000 meters, or a little under 20,000 feet. Beyond active volcanoes like Viva Savant, Cors, and minor lava flows in the northern reaches of Lake Confluctus, there are a few apparent volcanic depressions, also called paterae, in the far north, though that is likely to be a result of the low spatial resolution. Another highlight was the detection of a 70-kilometer tall volcanic plume at Prometheus. It was one of the more consistent plumes during the Voyager and Galileo missions, earning it the nickname Old Faithful. The ground track for this weekend's flyby is similar to the one from July. What we'll see in this weekend's images will be much the same as the PJ55 data, but at better spatial resolution. This means better images of Io's north polar region and northern trailing hemisphere. The best resolution images will have a scale of 7.8 kilometers per pixel. To give you an idea of what this kind of improvement will look like, here are a pair of images from Galileo at roughly similar resolutions as the best images from PJ53 and those planned for PJ55. In this example, the shapes of flows within Hyakka, Shamshu, and Kotar, near the center of these two images, become more distinct, and smaller scale features are now resolved. Much like PJ51, during PJ55, Juno's high-gain antenna is tilted slightly away from Earth as a way to allow for hours of continuous monitoring of Io, though available data volume will still place limits on how many images JunoCam and Juno's infrared instrument, GIRAM, can acquire. This will mean improved summed GIRAM products, as there will be more overlapping frames, making it easier to spot faint hotspots. For JunoCam, this will allow for greater surface coverage across perhaps 2 hours of imaging. This means more areas to look for plumes along the limb and terminator, and to search for surface changes since New Horizons, Galileo, and even the last Juno flyby. With the improved resolution of the JunoCam images, scientists will be better able to map terrain types across the North Polar region and to search for volcanic depressions. A key question we'll be trying to answer is how Io's lithosphere might differ at the poles compared to the rest of Io, and observing the size of features like mountains and volcanoes might hold a clue. As this is the last of the more distant encounters leading up to the Io flybys in late December and early February, PJ55 also provides a last opportunity to observe some parts of Io, like the area around Isum, Voland, Giru, and southern Lake Confluctus, until the European Space Agency's JUICE spacecraft arrives in 2031. Questions JunoCam images could answer about this region include what surface changes occurred at the fissure east of Giru Patera as a result of several mini outbursts that have occurred over the last 16 years. How do the changes at Voland relate to pre-existing features seen by Galileo in 1999? And what connection, if any, is there between Isum Patera, and southern Lake Confluctus. After this weekend's encounter, there are only 10 weeks before the first of 2 close flybys of Io on December 30th. Images from these encounters will rival some of the best global color coverage from Galileo and will be the best we can expect until the arrival of Europa Clipper. There is a plan to leave Juno in an Io resonant orbit after Perigeo 58, so hopefully we'll see even more of Jupiter's volcanic satellite over the next 2 years, this time covering Io's southern hemisphere. Thank you for watching.